Good morning, everyone. Our topic for today is investigate different brake system. So our objectives is at the end of the lesson, the student should be able to know the main function of brake and shock absorber, value the main purpose of the lesson, manipulate the every parts of brake and shock absorber. So before we proceed to our main topic, I just want to leave one question. So when we say or when you hear brake system, what comes into your mind? So brake system, brake are one of the most important component in the vehicle. So si brake system daw ay isang importanteng component din, no? Isa sa importanteng component ng ating mga vehicles, no? Kung pag-uusapan natin yung magagandang performance ng mga vehicles, no? So mamaya meron tayong two types of brake system. Include dito yung ating disc brake and drum brake. So explain ko sa inyo kung ano-ano yung mga parts na nagpapagalaw doon sa ating disc brake and drum brake to stop or to reduce yung speed ng ating vehicle. So, si brake system is siya yung papa-stop doon or nagpapabagal ng pag-andar ng ating vehicles when the vehicle is moving. So, parts of brake system. So, dito sa parts of brake system, no, tatako na tayo doon sa sinasabi ko kanina na two types of brake system, which is yung disc brake and drum brake. So meron din tayong pag-uusapan tungkol sa mechanical, hydraulic, and air brake system, no? Included din sila dito. So next natin is disc brake. So disc brake, the pressurized fluid enters the brake caliper, forcing the brake pads to move inwards again to revolving disc, no? So dito sa ating disc brake, no, once na press natin yung ating brake pedal, si brake fluid is magko-compress siya, no? And once na nag-compress na yung ating brake fluid, is matutulak nito yung piston doon sa ating mismong caliper. Then si piston is itutulak naman niya yung ating brake pad. And dito na magi-start yung friction, no? Nagki-create na ng friction to stop or to reduce yung ating vehicle, no? And once na napa-stop na niya, no? Syempre, yung ating brake fluid is aakyat ulit yun, no? Kasi binitawan na natin yung ating brake pedal, no? So, ayan, no? Nakikita nyo sa aking presentation ang parts of this brake, no? Meron tayo dito ang pad clip, pin boots, mounting bracket, lock pin, cylinder body, bleeder screw, bleeder cap, piston seal, piston boot, piston ring, shame, and pad, and guide pin, no? So itong mga to is ito yung mga nagpapagana sa ating disc brake parts, no? So unahin na natin dito yung disc brake, no? So kung nakikita nyo or na-observe nyo sa ating mga disc brake, no, is nakakabit siya doon sa hub ng ating vehicles. And kung nakikita nyo, yung napapansin nyo yung mga butas-butas doon sa gilid ng ating mga disc brake is, ang purpose nito is yung ventilation and para maiwas yung overheating or pagkasira ng ating mga brakes. And makaiwas din, no? Once na marami kasi itong mga dumi or napupuntahan ng dumi, mga dust, no? Nakakasira ito doon sa pag-compress or pagpapa-stop ng ating vehicles, no? So next natin dito is yung pad clip. So si pad clip is siya yung humahawak, no, doon sa ating brake pads, no? At kasunod nga nito is yung ating mountain name bracket, no, kung saan dito pinapasok yung ating sa loob nito pinapasok yung ating brake pads, no. At si mountain name bracket is siya yung nakakabit doon sa ating vehicle mismo, no, which is pag binuo siya is yung caliper mismo yon, no. And meron tayo ditong guide pin, no. Si guide pin is siya mismo or siya yung nag-guide doon sa ating brake pads, no. Once na na-press yung ating brake pedal and tulad nga ng sabi ko kanina, no, once na compress yung brake fluid, no, gumagalaw itong mga to reduce yung speed ng ating vehicle. And next dito is yung piston seal, piston and piston boot and piston ring. So kung mapapansin nyo, no, meron kung ano ang meron doon sa ating transmission or sa ating engine mismo pala. Sa ating engine, no, meron din yung ating brake system, no. So dito sa brake system naman, ang purpose naman ni piston is siya yung tumutulak once na nag-compress yung brake fluid, no. Brake fluid, siya yung tumutulak doon sa brake pads natin para ma-reduce din, no, yung speed ng ating vehicle, no. So dagdag ko lang, no, kay guide pin, so tinutulungan niya si piston, no, para doon sa pagtulak, no. Siya yung nag-guide once na tinutulak na ni piston yung brake pad natin. And next natin is yung bleeder screw and bleeder cap, no. So dito sa bleeder screw and bleeder cap, dito natin pinapalabas yung mga excess fluids, no, once na tayo ay nagbi-bleeding, no, yung mga maruruming fluids, no, pag pinapalitan natin yung fluids natin, brake fluids natin, no, dito natin sila pinalalabas. Then dito rin natin pinalalabas yung mga hangin na pumapasok doon sa ating brake lines, no, kasi once na nagkaroon ng hangin yung ating mga brake lines, no, possible na masira or hindi gumana yung ating brake system. Kasi kung mapapansin natin, no, doon pag nagbe-brake tayo ng mga vehicles natin, no, especially sa mga hydraulic vehicles, no, once na lumubog yung ating brake pedal or brake lever, possible na may hangin ito sa loob, no, maraming bula. So yun yung tinatanggal natin once na tayo ay nag-bleeding. So ayun, no, nalaman nyo na ang mga function and parts ng ating disc brake, no. So let's proceed naman tayo sa investigate and check the disc brake, no, or ano yung mga maintenance na ginagawa natin dito. So based on my experience, no, nung ako ay pinagtrabaho about dito sa mga disc brake and drum brake na to, no, ang na-observe ko lang, no, na mini-maintenance dito, no, una dito is kailangan natin na i-check yung mga fluid, no, hydraulic fluid, yung brake pads, and syempre yung mga guide pin and piston nito, no. Once kasi na nasira or na-stuck itong mga piston na to, possible hindi na rin gumana yung ating brake pads. dahil hindi nga na lubricate ng maayos. Once na hindi na lubricate ng maayos yung ating guide pin and piston, no, may stuck ito and magkokos ng pagkasira ng ating brake system, no, or magkaroon ng any accident na mangyayari doon kung sino man yung nag-drive ng ating vehicle. So, sa pag-check ng ating brake pad, no, tinitignan natin dito kung yung thickness ng ating brake pad, no, or so dito sa brake pad natin, no, may makikita tayong gatla na tinatawag, no. Once na lumakpas na doon yung pudpud ng ating brake pad, no, pwede na natin silang i-replace and palitan ng panibago, no, kaysa naman magkaroon pa ng accident, no, kasi once na pudpud na to, no, may hirapan ng mag-create ng friction, no, to stop or to reduce yung speed ng ating vehicle dahil nga kulang na siya sa force, no, to compress yung ating disc brake.
Welcome to Bendix Brakes. Today we'll look at how a modern disc brake system works. We'll start by looking at the brake components involved in stopping a vehicle and how they work together. Starting with one of the main components in the braking system, we look at the disc rotor, which the brake pads squeeze against. This will create friction that decelerates the rotation of the wheel and the vehicle. The caliper is activated by the brake fluid hydraulic pressure produced from the vehicle's brake pedal and master cylinder. In this assembly, the brake pads are squeezed up against the disc rotor surface to create friction. A caliper is made up of multiple parts, all critical in the effective operation of the brake system. These parts include the caliper and mounting bracket, slide pins, locking bolts, dust boots, brake mounting clips, brake pads and shims, the brake piston with the dust boot and seal. The caliper is fed brake fluid through a banjo fitting, which drives the piston forward towards the inside brake pad when the brake pedal is pushed. This causes the caliper to move along the slide pins, which then pulls the outside brake pad up against the brake disc rotor. Now that we understand the parts, let's see how the braking system works. Hydraulic brake pressure will cause the caliper to move along the slide pins, pulling the outer brake pad against the opposite side of the disc rotor, causing friction and decelerating the brake and the vehicle. When the brake pedal is pressed, the caliper will receive high pressure brake fluid from the master cylinder, which will push the piston into the inside brake pad and onto the disc rotor surface. Looking at the braking process from another angle, we can see the brake fluid pushing the piston, which in turn pushes the inner brake pad against the inside of the disc rotor. Once this has happened, the fluid will now push the caliper along the slides and the outer brake pad will be pulled towards the opposite side of the disc rotor. Thanks for tuning in. We hope you've learned the fundamentals of how Bendix brake pads work with a modern braking system. And always remember to fit Bendix brakes.
So ayun, next natin is drum brake, no? The pressurized fluid now enter the brake cylinder inside the drum brake. There are piston inside the cylinder. So meron tayo dito ang tinatawag na cylinder, no? Ito yon, yung nakikita nyo. Ayan, cylinder yung tawag dyan. Then sa cylinder na yan, wheel cylinder ang tawag, no? And sa cylinder na yan, mayroon ditong piston na tumutulak, no, doon sa ating brake shoe to stop or mag-create ng friction, no, para mag-stop yung ating vehicle or yung ating wheels, no, to stop the movement. Then their piston move towards because of the brake pressure, no, pressurized fluid inside the cylinder. This outward movement of the piston cause the brake shoe, no, yung sabi ko nga kanina, no, si brake shoe yung nagka-create ng friction, no, para mapa-stop natin yung ating vehicle. Yan. The brake shoe move towards the rotation drum. When this brake shoe rub, no, so yung brake shoe rub yung makikita natin yung sa gilid, no, brake shoe rub. Again, the drum brake friction is converted to kinetic energy into heat energy, and there be stopping your vehicle. So ayun, no, ganun lang din yung process niya, katulad kay disc brake, no. Si disc brake, tinutulak din siya ng piston, no, yung brake pad tinutulak din ng piston. Then we have a guide pin and lock pin na nag-guide doon sa ating disc brake para may tulak or to compress yung dalawang brake pad, no, para mapa-stop natin yung ating vehicle. And dito sa drum brake, no, usually nakikita natin ito or ginagamit itong drum brake sa mga heavy vehicles, no. Bakit siya ginagamit sa heavy vehicles? Kasi si drum brake is mas makapit siya, no, compare doon sa disc brake. Kasi si drum brake, yung buong wheels, no, nakakabit kasi siya dun sa wheel hub mismo, no, yung wheel hub. So yun, no, once na naglapat yung mismong brake shoe niya doon sa gilid, no, mas napapatigil niya yung mga mas mabibigat na vehicle, no, tulad ng mga truck, no. And usually meron din tayong makikita ng mga vehicle na double brake, no. Meron siyang disc brake and drum brake. Makikita rin natin yan sa mga 4x4 na mga vehicles. So yun, so mamaya pa may papanood ako sa inyo na videos, no, about dito kay drum brake. Then tatanong ko naman sa inyo, bakit kaya double purpose yung ating drum brake, no? Bakit kaya double purpose ito? So yung sagot nyo, no, pakilagay na lang sa comment section once na in-upload ko to doon sa ating MS Teams. Then sasagutin ko na rin yung tanong ko dito, no. So double purpose siya. Bakit? No? Meron siyang gamit sa foot brake and meron siyang gamit sa hand brake, no. Yung tinatawag natin na emergency brake or parking brake. So once na ginamitan natin siya ng foot brake, i-compress nito yung fluids, no, fluids yon. Once naman na hinatak natin, no, yung emergency or parking brake natin, mechanical brake naman yung pinapagana dito. So sa ating emergency brake or parking brake, ina-adjust ito, no. Kung mapapansin niyo sa mga nagdi-drift na mga drifter natin na no, mga drifter, mas mabilis silang makapag-drift once na ginagamit nila yung brake lever, hindi, 'di ba? Mas na ginagamit nila yung brake lever, mas mabilis lang nakapag-drift. Bakit? Kasi yung agwat nung or yung distance nung mechanical brake nila, no, naka-adjust na yon. So once na mag-adjust tayo, dito tayo sa corona na tinatawag, yun dito sa gilid, may makikita tayo kadalasan sa mga drum brake, yung bilog para siyang corona, no, yun yung ina-adjust, or yung ring, yun yung ina-adjust. So iniikot yun, and once na inikot mo yun, yung pinaka ano natin dito, tag dito yung mechanical natin, no, nauusog yun, and unti-unti, no, nababawasan yung distance, no, umiikli. And once na ginamit natin yon, no, kailangan ang alam kong standards is 7, no, 7 clicks sa mga private vehicle, 7 clicks, no, pag tayo gumagamit ng parking brake or emergency brake. So yun. So ayun, no, punta naman tayo sa parts ng ating drum brake. No, dito makikita natin dito sa ating parts of drum brake, no, drum, brake cylinder. So ito yung tinasabi ko kanina na merong piston, no, brake cylinder or wheel cylinder na tinatawag. And ayan, nakalagay, nakaturo naman, no, may piston siya. So we have a 2 piston, no, to create to compress yung ating dalawang brake shoe pala, dalawang brake shoe, no, para madikit doon or malapat doon sa gilid ng ating mismong drum. And we have emergency brake lever. So ito yung sinasabi ko kanina, we have double purpose nga siya, no, we may mechanical and yung hydraulic. So ito yung sinasabi ko kanina, ito kung makikita nyo, no, yung adjuster basta yan, adjuster, ayan yung ina-adjust, no. So ito makita natin itong springs, no, ayan, ina-adjust itong adjuster na to once na ginagamit natin yung ating emergency brake or parking brake, no, para mapaikli natin yung distance ng brake lever natin, no. So may bilang ito, yung sinabi ko nga kanina, no, yung standards yata ng sa Toyota, sa Toyota yon, no, meron silang standard sa mga private vehicles na 7 clicks lang para mas mabilis yung pagre-react ng ating drum brake once na tayo ay nagpa-parking. Kasi once na mas mahaba yan, mas matagal or mas delikado para sa mga nagmamaneho or sa mga drivers natin. So yun lang naman yung mga parts ng ating so dito yung likod niyan is may backplate na tinatawag, no, backplate, yan. Ayan, ito yung gilid is brake shoe and brake shoe line, no, na makikita natin. So dito is may ipapanood na akong video about sa drum brake.
Drum brakes are usually used as rear brakes in automobiles. Let's go through the parts involved in the system and see how it works in detail. Brake drum acts as the braking surface on the wheel side. Wheel hub, the part to which the brake drum and the wheel are attached to. Let's have a closer look with the wheel hub off. Backplate, this holds all the brake components together. Brake shoes, these will be pushed against the inner surface of the drum. The friction between the lining and the drum is what makes the wheels to slow down. Hold down spring holds the brake shoes towards the backplate. Retaining springs returns the brake shoes to its resting position. Wheel cylinder, the hydraulic part which pushes the brake shoes. Modern drum brake systems are self-adjusting. which means when the lining wears out, the system adjusts the brake shoes towards the drum. For that, the system uses a brake adjuster, adjuster lever, adjuster spring. The wheel cylinder receives the force that we applied on the brake pedal. At the back of the wheel cylinder, there is an inlet port to receive the fluid, and a bleeder valve to remove air in the system. Let's have a look at the exploded view. The cylinder body, dust boot, pistons, piston cups, piston cup expanders, return spring. When force is applied on brake, hydraulic fluid pushes the wheel cylinder pistons, which pushes the brake shoes. This action creates friction between the brake liner and the inner surface of the drum, and brings the automobile to rest. The adjuster makes sure that the brake liners remain close to the drum as the liners wear down. As you can see, it uses a screw mechanism to increase its length between the shoes. Each time the car brakes while in reverse, the cog is pulled down by the pin to push the shoes against the drum. And that's how a drum brake system works. Stay tuned for more presentations from Autotech Labs.
And is brake master cylinder. So dito sa ating brake master cylinder, the master cylinder is basically a plunger that is activated by the brake pedal. So once na press natin yung ating brake pedal, no, yung brake fluid natin is nag-activate or nako-convert siya into force, no, para maitulak nito, para maitulak nung brake fluid natin yung ating piston to create friction, no, para mapa-stop natin yung ating vehicle. So yun yung trabaho ng ating master cylinder. So dito sa ating master cylinder, we have a 2 piston din na ating tinatawag. Bakit? Meron itong port, no, na tinatawag para sa ating brake drum end dun sa ating disc brake, no. Kaya meron siyang 2 piston din na pinagkukunan para makapag-create ng force. So kung ito nakikita yung 2 hose ito no, ito yung 2 port para mapasukan ng ating brake fluid. Then yung nasa top naman ng ating master cylinder, ito yung tinatawag natin na reservoir or lagayan ng ating brake fluid. So tuloy ko lang yung pagbabasa. It is what holds the brake fluid and force it through the brake lines. So yun nga, tulad nga ng sabi ko kanina, once na nagkaroon na ng force, no, or nag-convert it into force na yung ating brake fluid, no, na itutulak na ito doon papunta sa ating brake lines, connect doon sa, like for example sa disc brake, connect na yun doon sa ating piston ng ating caliper, and si caliper is itutulak na yung ating brake pad.
The brake master cylinder is an important component of a vehicle. Brake master cylinders convert the force of the foot or fingers into hydraulic pressure. A brake master cylinder is almost always a tandem brake master cylinder that will be described in this animation. First, we will explain the brake master cylinder with compensating ports. This master cylinder has a reservoir tank which contains the brake fluid and a cylinder. Rubber piston cups are located in the cylinder. The rubber piston cups form brake circuits. Since there are 2 brake circuits, such a master cylinder is called tandem brake master cylinder. The ports of the master cylinder are located in the top part of the cylinder. The outlet ports for the brake lines, which are connected to the brakes, are located on the side of the cylinder. As soon as the driver depresses the brake pedal, the push rod pushes the first rubber piston cup over the compensating port. Consequently, pressure builds up in the first brake circuit. As a result, the second rubber piston cup is moved over the second compensating port and pressure builds up in the second brake circuit. Occasionally, brake lines can leak or snap. For this reason, split brake systems are mandatory in many countries. If one brake circuit fails, the second one still works. Passenger vehicles typically have either a front-rear split brake system or a diagonal split brake system. In the front-rear split brake system, the first brake circuit provides pressure to the front brakes. The second brake circuit provides pressure to the rear brakes. In the diagonal split brake system, one brake of the rear wheel and one brake of the front wheel are supplied by one of the two brake circuits. Portless master cylinders are used in conjunction with ABS. This type of master cylinder has no compensating port. Brake fluid flows into the cylinder through the breather port. The breather port provides the brake circuit with brake fluid when the intake valve is open. As soon as the valve is closed, pressure is being built up in the brake circuit and the vehicle is being braked.
So, ayun guys, no? Or classmates. Kung napapansin nyo, dito sa nire-report ko is all about the main parts na ng ating brake system. So, kanina, kung nakita nyo, or napansin nyo, no, yung two types ng brake system yung nire-report ko. Dito naman is yung kabuuan na ng parts ng ating brake system, kung paano or saan nagmumula yung pagki-create ng para mapa-stop natin yung ating vehicle. So, next natin is brake lines. So, generally made of steel. Brake lines are what carry the brake fluid from the master cylinder reservoir to the wheel where pressure is applied to stop the car. So ayun, no, alam naman natin na ang brake lines or brake hose dito, this is the passage ng ating brake fluid, no. Once na pinipress na ni driver yung brake pedal, dito dumadaan, no, yung ating brake fluid galing sa ating master cylinder, no. Yung kino-convert into force, dito siya dumadaan. And once na tinanggal ni driver yung kanyang paa doon sa brake, no, or parang engage and disengage yung nangyayari dito, once na dinisengage ni driver yung pagbe-brake, no, yung brake fluid babalik lang siya, no, hindi man totally babalik. So meron pa rin siya dun sa brake lines, pero yung force na nakikreate nun is mawawala, no. Then babalik lang siya once na prenes ulit ni driver yung brake pedal. Then ang isa pang trabaho nito, no, parang siya din, so yung ibang brake fluid siya din yung nag-holds, no, bali hindi na natatanggal dun sa loob ng brake. So next natin is wheel cylinder. The brake pads are connected the wheel cylinder, which it has squeeze this brake or push apart drum brakes the brake pad when fluid flows into them. So ang trabaho naman nito ni wheel cylinder, no, siya yung nagpo-push ng ating disc brake and drum brake, no. So kung mapapansin nyo dun sa ating caliper, meron siyang piston, no, tulad nga ng sinabi ko kanina doon sa unang part ng ating lesson. Doon sa caliper, ang tawag doon is yung piston yung tumutulak doon sa ating brake pads, no, siya yung nag-squeeze para mapa-stop natin yung ating wheels, no, siya yung nagke-create ng friction to stop the wheels or yung movement ng ating vehicle. Same din nito yung sa drum brake. So ito yung nakikita natin, yung wheel cylinder, sa drum brake siya nakalagay. Bakit? Dalawa kasi yung piston na ginagamit niya, and mas comfortable ito para sa drum brake kasi 2 brake shoe din yung ginagamit dito para mag-create din ng magkaroon ng increase yung movement ng ating vehicle. So ang next natin is the flow of brake system. So paano nga ba nagpo-flow yung ating brake fluids, no, na nagagaling sa ating reservoir papunta doon sa mismong brake, no? So ito, explain ko sa inyo kung paano nag-flow ito papunta doon sa ating disc brake and papunta doon sa ating drum brake, no? So once yung driver, like for example, yung driver natin is nagda-drive, no, mahaba na yung nababiyahe niya and kailangan niya mag-stop, then kailangan niyang i-press yung magpipress siya ng brake pedal, no. So once na press niya yung brake pedal, no, mapupunta ito doon sa ating vacuum and mapupunta siya sa master cylinder, which is si master cylinder, siya yung nagdi-distribute, no, nagmo-multiply ng fluid into 2 para doon sa disc brake and drum brake, no. Then once na na-distribute na niya, mapupunta ito doon sa ating brake lines. So we have 2 types of passage ng ating vehicle. Meron tayong, pag sa front, meron tayong tinatawag na brake hose, and meron naman tayong tinatawag na brake lines pag ito yung ginagamit sa rear naman, which is dun sa ating drum brake. And next nun, once na na-delivered na yung force or yung fluid papunta doon sa ating mismong caliper, so si fluid ipupush niya yung piston paloob or palabas para ma-squeeze yung tatamaan niyang brake pads, no. Then dito sa caliper na to, we have guide pin and lock pin na tinatawag, no. So, ang purposes nito is para matulungan niya si piston, no, to squeeze, no, yung ating yung ating rotor mismo, no. Then dito na magpo-force na ma-stop or mapahinto yung ating vehicle or ang ating wheels. So dito sa part na to may papanood din akong video sa inyo para mas maunawaan nyo kung paano nga ba nag flow itong ating brake system or yung ating fluids, no. So so ayun, no, meron din akong isang question para sa inyo, no. So sa tingin nyo, once na si driver is pre-nest or naglagay ng pressure doon sa ating fluids, no, ano kaya yung unang nadideliveran ng fluids or ng ating brake fluids ng force, no, para magkaroon ng stop movement? Sa tingin nyo, yung front brake ba or yung rear brake ba yung nauuna niyang bigyan ng force para mag-stop yung ating vehicle? So pag sasagot kayo, no, comment down na lang kayo or sulat nyo sa papel, and then so ayun, no, kung napapansin nyo sa ating presentation, no, we have three types of brake system. I don't know if it is types ng brake system or component, ganun, hindi ko po kasi alam eh. So actually nilagay ko na lang talaga sa three types of brake system, no, kasi ang alam ko sa types ng brake system is yung disc brake and drum brake lang, diba? Yun yung pagkakaalam ko. So ayun, no, let's proceed na tayo sa ating first type ng brake, which is the mechanical brake. So mechanical brakes are assemblies consisting of mechanical elements for the slowing or stopping of shafts. In equipment drives, they use lever or linkage that transit force from one point to another, braking, slower, or stopping the movement of coupled shaft. There are several types of mechanical brakes. So ayun, si mechanical brakes is usually nakikita natin to sa mga bikes natin. So kung i-compare natin siya doon sa hydraulic brakes, no, si mechanical is ginagamitan lang siya ng wire na nagki-create din, no, para mag-squeeze yung ating brake pad, no, to stop yung ating vehicle movement, no. So meron siyang parts na tinatawag dito, no, nabasa natin dito yung lever and linkage niya. So yung lever, once na lagay ka ng pressure doon sa lever na yon, no. So si linkage, ito yung wire, no, or yung nagli-link dito sa ating rotor, no, to create, no, ng pag-increase ng ating vehicle movement. So yun, no, ito yung isa sa ating types ng ating brakes. So ayun, no, ang next naman natin is hydraulic brake, no. So may tanong dito nakalagay, what is a hydraulic system? A hydraulic system is a drive technology where a fluid is used to move the energy from an electric motor to an actuator, such as hydraulic cylinder. The fluid is theoretical and compressible. the fluid path can be flexible. So yung mga path natin na tinatawag dito is yung passage, no? Kung saan dumadaan yung ating mga fluids, no? So mga flexible path daw yung mga flexible, so na-expand ganun, no? Is the same way as an electric cable, no? So next natin is, what is hydraulic system used for? Hydraulic system are mainly used where a high power density is needed or load requirements change rapidly. This is especially the case in all kind of mobile equipment such as excavator and is industrial systems such as presses, no? Turbines. Hydraulic is used for pitch or brake control. So yun, kung alam niyo yung wind turbines, ito yung mga nakikita natin sa ibang lugar, yung windmill, no? So si wind turbine, siya yung nagke-create ng friction para magkaroon ng electric process or electricity yung isang lugar, no? Once na nagke-create or once na umiikot yung wheels or yung fan nun, no, nagke-create yung turbine natin ng electrical or electric, no? Then hydraulics is used to pitch and brake control, no? Yun na, nagko-control siya. In some cases, different auxiliary system. So dito sa mga auxiliary, no, sila yung nagme-maintain or nagpapagana, no, sa isang parts, no. Pagkakaalam ko, may mga pressure yung mga auxiliary na yan, eh. Such as hatch and cranes are also powered by hydraulic system. So based doon sa based sa experience ko, no, sa mga auxiliary, sa forklift kasi, ang gamit ng auxiliary dun, napapasukan siya ng mga fluids, eh. And then yung fluid ay yung auxiliary, sila yung nagtutulak ng fluids papunta dun sa mga hoses. So parang nagke-create sila ng force, kino-convert nila into force yung fluid para maiangat yung isang bagay or maitulak yung isang bagay. Ayun. So next natin is air brake system. So dito sa ating air brake, no, air brake, an air brake, or more formally a compressed air brake system, is a type of friction brake for vehicle in which compressed air pressing on a piston is used to apply the pressure to the brake pad needed to stop the vehicle. So usually itong air brake system na to, nakikita natin to sa mga heavy vehicles like a truck, no. So kung mapapansin nyo or nag-observe kayo sa mga truck, once na tumigil yung truck, no, may maririnig kayong sounds na parang may hangin, no. So ibig sabihin, nagpe-press yun, pinipress yung brake nun, then lalabas, no. Compressed air yung ginagamit dito para mas mabilis tumigil yung mga vehicles, no. So once na may nasira dito sa part ng ating air brake system, no, possible na magkaroon ng problema talaga, no, or any accident once na hindi natin naagapan yung mga problem dito compare sa mga vehicles natin na kotse, no, or mga sedan. May mga pang-agap tayo na brake, no? Like for example, yung emergency brake. I don't know kung sa truck is may emergency brake din eh. Hindi ko sure yun, no? So, yun yung tatlong type ng braking system natin.
Drum brakes have a drum attached to the wheel hub, and braking occurs by means of brake shoes expanding against the inside of the drum. With disc brakes, a disc attached to the wheel hub is clamped between two brake pads. On light vehicles, both of these systems are hydraulically operated. The brake pedal operates a master cylinder. Hydraulic lines and hoses connect the master cylinder to brake cylinders at the wheels. Most modern light vehicles have either disc brakes on the front wheels and drum brakes on the rear, or disc brakes on all four wheels. Disc brakes require greater forces to operate them. A brake booster assists the driver by increasing the force applied to the master cylinder when the brake is operated. A power booster or power brake unit uses a vacuum to multiply the driver's pedal effort and apply that to the master cylinder. This increases the pressures available from the master cylinder. Units on gasoline engines use the vacuum produced in the intake manifold. Vehicles with diesel engines cannot use manifold vacuum, so they are fitted with an engine-driven vacuum pump. The most common booster operates between the brake and master cylinder. It increases the force that acts on the master cylinder. Whenever the brake pedal is depressed, a pushrod opens the vacuum control valve. The level of assistance this power boost gives depends on the pressure applied to the brake pedal. The anti-lock braking system prevents wheel lock or skidding, no matter how hard brakes are applied or how slippery the road surface. Steering stays under control and stopping distances are generally reduced. It consists of a brake pedal, a master cylinder, wheel speed sensors, the electronic control unit or ECU, and the hydraulic control unit, also called a hydraulic modulator. The ABS control module, or ECU, sends commands in the form of electrical signals to the hydraulic control unit. This unit executes the commands using 3 solenoid valves connected in series with the master cylinder and the brake circuits. 1 valve for each front wheel hydraulic circuit, and 1 for both of the rear wheels. In normal non-ABS braking, brake pedal force is transmitted to the master cylinder, then through the solenoid valve to the brake unit at the wheel. When the signals from the wheel speed sensor show no tendency for the wheel to lock up, the ECU does not send any control current to the solenoid coil. The solenoid valve is not energized, and the hydraulic pressure from the master cylinder is supplied to the brake unit at the wheel. When the control unit detects any lock-up tendency, perhaps from too rapid wheel deceleration, it sends a command current to the solenoid coil. This causes the armature and valve to move upward and isolate the brake circuit from the master cylinder. That keeps the pressure between the solenoid and the brake circuit constant, regardless of whether or not the master cylinder hydraulic pressure rises. If the sensors signal continuing excessive wheel deceleration, the control module sends a larger current to the solenoid valve. This lowers the braking pressure by moving the armature up further, opening a passage from the brake circuit to an accumulator, a temporary reservoir for any brake fluid that flows out of the wheel brake cylinders because of the fall in pressure. A return pump sends this brake fluid back to the master cylinder. If the sensors then signal that the lower pressure has allowed the wheel to speed up, the ECU stops all command current, which de-energizes the solenoid valve. The pressure rises, and the wheel is again slowed down. Whatever the phase of operation, pressure in the circuit can never rise above master cylinder pressure. Modern cars use tandem master cylinders to suit divided or dual-line braking systems. A divided system is safer in the event of partial failure. Fluid loss in one half of the system still leaves the other half able to stop the vehicle, although with an increase in stopping distance. A wheel's braking ability depends on the load it's carrying during braking, so the type of vehicle is a major factor in how its system should be divided. A front-engined, rear-wheel drive car has around 40% of its load on its rear wheels, so its braking system can be divided in a vertical or front-rear split. This puts the front wheels in a different system from the rear wheels. If one half of the system fails, the front or the back, there's still enough separate braking capability left in the other half to stop the vehicle. This doesn't work well for a front-wheel drive vehicle. A load of about 20% on the rear wheels can't provide enough braking force to stop the vehicle. Front-engined, front-wheel drive vehicles use a braking system split in a diagonal, or X. The left-hand front brake unit is connected to the right-hand rear unit, and the left-hand rear to the right-hand front. If one system fails, a 50% braking capability is left in the other system. Dual proportioning valves maintain optimum braking in each system. A system that partially failed would cause severe braking pull on a vehicle's suspension, so suspension geometry is usually revised to counter this. An alternative arrangement for front-engined, rear-wheel drive vehicles is an L-split. The front disc brake units have 4 piston calipers. 2 of the pistons on each front unit connect to the right-hand rear, and the other 2 pistons of each unit connect to the left-hand rear. As with the X-split, if there is a failure of either half of the system, it still leaves 50% braking capability.
So ayun, let's proceed na tayo sa ating next topic, which is investigate different shock absorber. So tapos na tayo sa ating first topic, which is yung investigate different brake system. So dito sa ating shock absorber, ito yung so ano nga ba sa tingin nyo, no? Yung shock absorber, no? So please write your answer in the comment or isend nyo, no? Isulat nyo and isend nyo sa akin yung mga may sasagot nyo based on your opinions, no? So si shock absorber, no, siya yung nag-maintain ng comfortable rides, no? It means, no, once na yung vehicle natin is nagra-ride, no, siya yung kumukuha lahat ng vibration simula sa engine from dun sa road, no, sa kanya napupunta yon. Then hindi natin mararamdaman yung mga vibration na yon, no, once na tayo ay may shock absorber. Pero kung wala tayong shock absorber, ramdam na ramdam natin yun, yung pag-alog ng ating vehicles, yung mga clicking sounds, no, mararamdaman natin yun. So shock or shock absorber are part of the vehicle, of your vehicle, responsible to maintain a comfortable ride. They perform one of 2 functions. First, they are designed to absorb the vibration, yung sabi ko kanina, jolts and bounce and experience while driving your vehicle, no? Second, they assist you keep all of your tires in contact with the road at all times. They aids and maintain good braking and handling ability. So, yun, yung nasabi ko na nga ito sa unang part, no, yung hindi ko pa siya binabasa. No? So, ayun yung trabaho ng ating shock absorber. So, next natin, no, dito sa part na to, is yung types na ng ating shock absorber. So, ano-ano nga ba yung mga types ng ating shock absorbers? So, ang first type ng ating shock absorber, which is itong conventional telescopic shock absorber. So, itong shock absorber na to is basic shock absorber siya, no? Itong type ng shock absorber na to is replaced rather than repaired, no? Nare-replace na lang siya, hindi na siya naaayos once na nagkaroon ito ng damage, no? So, pag na-reach na yung lifespan niya, no, nire-replace na tong shock absorbers na to. So, ayun. So, may papakita akong video sa inyo kung paano nga ba nagpa-function itong shock absorber na to. And paano yung flow nito once na ang isang vehicle is on the road, no.
The shock absorber is one of the fundamental elements of the vehicle suspension system. Its function is to stop spring oscillations, providing control, grip, stability and comfort to the occupants of the vehicle. Shock absorbers today are hydraulic devices, i.e. they work on the basis of oil flowing through valves, the damping rate of which is sensitive to the speed of the piston. Therefore, the faster it moves, the more resistant the shock absorber is to movement, thus becoming more rigid. The most common type of shock absorber currently used in motor vehicles is the hydraulic telescopic type. Although there are other variants on the market, most units are built with 1 or 2 cylindrical steel tubes with a rod moving up and down inside, which is attached to the vehicle. The system includes calibrated valves that allow compression and rebound forces to be adjusted by controlling the oil flow through them in different driving situations.
When things get shaky, we turn to our expert, Pat Goss. So let's head on down to Goss's garage and smooth things out.
A car that bounces as you go down the road can be very tiring and very annoying. And keeping it from bouncing is the job of the shock absorbers or the struts, whichever your car happens to have. Now, the way you test them is a couple times a year. You go around each corner of the car and bounce it up and down like I did this one. And what's going to happen is it's going to go like this. You let go of it in the down position, and if the shock or strut on that corner of the car is good, it'll come back to the center and it will stop. It won't continue to bounce. If it continues to bounce, probably you need new shocks or struts. But what's the difference between a shock absorber and a strut? Well, here we have an example of a strut. Now, what this does is it has a shock absorber in the middle, and then around it, it has a spring to support the weight of the vehicle. A shock absorber, on the other hand, such as we have here, these shocks do not have the springs on them. They have nothing to do with the height of the vehicle or anything like that. The only thing they do is to keep the car from bouncing. The spring is mounted someplace away from the shock. Now, a shock or a strut, whichever it is, all they do is convert the vertical movement of the car into heat energy. They dampen it so that you don't go down the road just kind of this motorboat effect floating along. Now, if you have bad shocks or struts, and they can wear out in as little as 50,000 miles, or it may be 150,000, but you should check them 2 or 3 times a year. And when they're bad, replace them in pairs, 2 fronts or 2 rears. Now, here's the thing. This shock right here, this one is worn out. If we push this down, we see that it comes back virtually immediately. Now over here we have a brand new one. This gives you an idea as to what these things do. As you see, this comes back very slowly. It's very controlled, and that's how it controls the ride of your vehicle. So check them on a regular basis, replace in pairs when necessary, and remember that if you don't replace them, you could have a dangerous car. That's number one. But number 2, you could have severe tire wear problems as the result of a bad shock or strut. And if you have a question or comment, drop me a line right here at Motor Week.
This video shows the animation of a leaf spring. So you can see the leaf spring actually moving, which is connected towards the axle. So as the wheel enters a hump, how the leaf spring reacts. The chassis actually won't be moving, but the suspension takes the shock. This is one of the most or the oldest suspension methods being used. It's also currently being used in trucks or bigger automobiles. Uh, Most of cars, etc., or modern vehicles in Europe use MacPherson strut like that, but in heavy equipments, the leaf spring technology is being used. So you can clearly see how a leaf spring responds to a shock or when it enters a hump, and how it takes the shock by limiting it, by not acting it on the chases on the top of it. So this clearly shows the animation and the working of a leaf spring. Thank you.